Hello guys, welcome back to Java session. In this particular video, we are going to cover Unit 3 regarding this collection framework and the different interfaces which are available under the collection and the classes which are implementing these collection interfaces. So this is the part we are going to cover in this particular video, right? Sir, what is this collection framework? Basically, this collection framework, it's a ready-made architecture. There we have different interfaces and classes. By using these interfaces and classes, what we are going to do, we are going to implement the various data structures and algorithms. That is the main motto of this collection framework, right? For example, if you are taking the linked list, it's a predefined class in the collection framework. By using this, what we are going to do, we are going to implement the double linked list data structure. So this is how we have the different uh, predefined classes and interfaces. By using them, what we are going to do, we are going to implement the various data structures and algorithms. That is the main motto of this collection framework, right? Sir, what else we can do by using these collection frameworks? You can achieve all operations which you can perform on a data. Like you can perform the searching operation, you can perform the sorting operation, you can perform insertion, you can perform deletion operation, you can perform manipulation operations. These are all the operations you can achieve by using these Java collections, right? So this, sir, how we are going to do? We are going to do all these operations by using various underlying data structures and algorithms, right? Sir, what is the architecture of this collection framework? But this is the collection framework architecture. Here, iterable is the main interface. Under this, we have the collection interface. Under this collection interface, we have the sub interfaces like list, queue, set. These are the three sub interfaces. Under these sub interfaces, we have the different classes. So under list, we have the array list, linked list, vector, stack. Under queue, we have the priority queue. It's a class. So here I differentiated with the color. The uh, boxes which are there with the yellow, they are all the interfaces. Pink, they are all the classes, right? Here, dashed line that shows the implements, and thick arrow that shows the extends. That means a interface can extend an interface. A interface can be implemented by a class. That is how I represented here, right? This is a complete collection framework which we are going to cover in our future sessions, right? Now, we are going to cover the first part. Sir, what is this list? What are the different classes and uh, classes which are implementing this list interface? That is the part I am going to cover now, right? Sir, do we have any predefined methods in the collection interface? Are they available to the sub interfaces? Of course, beta. We have different methods which are there under the collection interfaces. They are all available to collection interface. They are all available to sub interface. Here I am going to discuss those methods, right? You have the add method, which is used to insert an element into the collection, right? You have add all, which is used to insert more than one element in a specified collection. If you want to remove element, then you can use remove, right? If you want to retain the elements, you can use retain, right? So if you want to find the size, then you can use size method. If you want to clear the elements, that in the sense, sir, I want to remove uh, all the elements from the collection, then you can use a clear method. If you want to know a particular element is there in the collection or not, then you can use contains method. It returns true if the particular element is there in the collection. Otherwise, it returns false. So if I want to find more than one, then you can use contain all, right? Then it returns true if the specified collection is available. Otherwise, it returns false. This is the way we have. You can find whether the collection is empty or not. Is empty method is there, right? This is how we have the various methods which are there in the collection interface, which are all available to sub interfaces. Now we will go with the sub interface. That is the list is the sub interface. First, I am going to discuss about the list interface. Then after that, we will discuss the set interface, then followed by queue interface, right? This is how we will go one by one. Now, this is the list interface is the sub interface of the collection, right? Whatever the methods which are there in the collection interface, they are all available to the list interface. So the classes which are implementing this list interface, they can use the collection methods, collection interface methods, right? This is the basically it's a child interface of the collection interface, right? Here, uh, inbuilt data structure of this list is list data structure only, right? There we can store ordered collection of elements, right? It can have the duplicate elements. So these are all the two properties of the list interface. Now, first we will discuss about the array list, right? Then followed by linked list and all. Yes, now I am going to discuss about the array list. Basically, this list interface is implemented by four classes. They are array list, linked list, vector, and stack. First, I am going to discuss about the array list, right? And this list also contains the various methods. They are also all the methods are available to array list, right? Sir, what is this array list means? It's a class beta. This is the class which is implementing the list interface. That is only the relation, right? Now, basically, this array list internally it uses the dynamic array. By using this dynamic array, it can store the duplicate elements, right? And duplicate elements of different data types, not the single data type. And this array list class, it maintains the insertion order. It maintains insertion order. And this array list is non-synchronized. Non-synchronized means you can access the elements in a random manner. And the elements stored in the array list class can be accessed in the random manner because they are non-synchronous or non-synchronized, right? These are the points you need to keep in mind while dealing with the array list. Sir, how we can create an array list? Beta, you can create an array list just by creating object to the array list class. Sir, where we have this collection framework? Beta, whatever the classes or interfaces which we are discussing regarding this collection framework, all the collection framework classes and interfaces are available under the util package. So whenever you are dealing with any class or interface, you should import the util package, right? So first you should import the util package, then you should create object to the array list class. It's a predefined class. That's what I'm creating object to the array list class. Just create object here. ARL is the object of the array list. Now, sir, what operations you can perform? Better you can add an element by using add method. You can add an element at specified position. Sir, I want to add the element at the second location. Of course, you can add. Sir, I want to remove an element. You can remove the element directly, or you can remove element at a specified position. Sir, I am passing 2. That in the sense, it will delete the second position element, right? And you can find the size of an array list by using this size function, and you can convert an array to array list. And sir, we learn somewhere else array. Then what is the difference between the array and array list? Beta, whenever you are dealing with array, once you are created array, the array size is fixed. But whereas this array list, it is implementing the dynamic array. That in the sense, it can this array list, it can grown automatically and it can shrink automatically, right? But here, whenever you are dealing with array, let's say, sir, I am taking an X array with size 5, right? That in the sense, what will happen? 5 memory blocks are going to be allocated. Sir, if I want to store the sixth element, this is not possible because it cannot grow dynamically. Whereas when it comes to the array list, sir, I am created an array list with size 10. If I want to store the 11th position element, yes, it can grow automatically. But what will happen whenever you are trying to insert the 11th element, the array list size will become increased. Sir, do we have any standard formula? half of the existing size plus 1. So half of the existing size is 5. 5 plus 1, that is 6. So existing array is 10. 10 plus half of the existing size plus 1. So 10 of is 5 plus 1, that is 6. So 10 plus 6 total, the array list size will become 16. Then what will happen? It will shift the first 10 elements which are stored in the existing array list object. Then only it will allow us to add the 11th position element, right? Then only we can use this array list. This is how too many shiftings will happen whenever you are dealing with the array list. Because of this, the performance of the array list will degrade, right? So memory wise, the array is best. Sorry. Whenever you are considering the memory, according to the memory, array list is best, right? According to the performance, array is best. So this is the difference between the array and array list. Now we will see example program on this array list.